I'm so glad you're here. I have a problem. I was given this question, and it said if I have 2 bags and I have to pull a red marble out of one of the bags, which one is more likely? And the reason why I'm so worried about this is that there's $500 on the line. Okay, if you get it right, you get $500, but if you get it wrong, you lose $500, and I'm really nervous about it. So here's the problem that I have. When they told me to get this question, they gave me 2 bags, and then they told me how many marbles are already in each bag. So in this bag, we have 3 red marbles, 2 blue marbles, and 4 green marbles. And in the other bag, we've got 4 red, 5 blue, 6 green, and 2 purple. So I have more red marbles, but I have more marbles overall. And I haven't been able to figure out which of these 2 things is more likely. So by the end of this video, I think we'll be able to answer that question together. So let's start talking about probability a little bit and see if we can get some ideas. Well, probability is the likelihood of something happening, and all probability is between 2 percentages. 0% is something that has no chance of happening. Okay, so my middle schoolers would say the chance of Mr. Schmidt ever being cool, 0%. Okay, so probability can go between 0% and 100%. If something is 100% likely, it is absolutely going to happen. Okay, so Mr. Schmidt would say the probability of Mr. Schmidt being cool is 100% because it's absolutely going to happen. Now, the thing about probability is you can't be above 100% and you can't be below 0%. Anything in between is going to be written as a decimal or a fraction or a percentage. You can use any of them, but probability is most often seen as 100%. Remembering that if we think about fractions, 0% is 0 over anything, where 100% would be like 6 over 6 or 8 over 8 or just the number 1. So then we got to think about experimental versus theoretical probability. So if we think about a coin, the chance of getting a heads of a coin, we know that there are 2 parts of a coin. There's heads and then there's tails. So when we think about theoretical probability, this is in theory what should happen. Okay, so this is what should happen. So when I write the fraction, I like to think of what we call part over total. So we're looking for a heads. So there is one side of a coin that has heads. So that's 1. And there are 2 total sides of the coin. So we have 1/2. Now, like I said before, probability can be written as a decimal or as a percentage. Well, we know that 1/2 is the same as 5/10, and 5/10 is the same as 50%. So that would be the theoretical probability of getting a heads. But if we did an experiment, let's say we flipped the coin 10 times. And in those 10, we got 6 heads and we got 4 tails. Then the experimental probability would be part over total. So we have 6 heads here and we have 10 total, which is 6/10 or 60%. So experimental probability is what does happen in an experiment. Okay, now here's the problem that I have when I was thinking about the question. If someone asked you about flipping a coin, you would say, well, you should get heads and tails equally. But when we did flip the coin, we got actually more heads than tails. So if I actually had to guess which is going to happen more than the other, the guess would be different than what actually happens in reality. And that's the case with all probability, that you can predict what's going to happen. But the opposite of what's predicted could absolutely happen. If something has a 1% chance of happening, it can absolutely take place once. It's luck of the draw. So let's look at a few examples, see if we can help us, decipher the difference between theoretical probability and actual probability. So with dice have 6 sides, numbers 1 through 6. So we know the total is always going to be 6 on the bottom of the fraction. So if we roll a dice once, what is the chance or theoretical probability that we land on 2? Well, we know that there are one side of a dice that has the number 2 on it, and we know there are 6 sides of the dice total. So 1/6. Now, in probability, because of the way we're working with fractions, if it's not a clean fraction that doesn't turn into 100 easily, you can use a calculator to estimate. So in this case, this is about 17% and about 17/100ths. So we know that we have a 17% chance, or 1 in 6 chance of getting a 2 when we roll the dice. But if I rolled the dice, I guarantee that if we rolled it 6 times, we wouldn't necessarily always get 1, 2. That theoretical probability doesn't always take place. So if we roll the dice once, what's the chance we hit a prime number? Okay, so prime numbers, that would be 2, 3, and 5. Well, 2, 3, and 5, there are 3 prime numbers on the dice, and there are 6 sides total. Well, 3/6, that's the same as a half, which, if we remember from before, is 50% or 5/10. Okay, so that's a 50-50 shot. And another way you can write it is this means probability of 2 or 5. You'll see this a lot in IXL. Well, 2 or 5, there are 2 options there. And there are 6 total sides of the dice, which simplifies to 1/3. 1/3 we know is about 33% or 33/100. So you absolutely do not need a calculator for thirds. Okay, so that's how dice look. But we don't always work with dice. What if we work with something like a spinner? Okay, so if we spin this spinner 10 times, how many times will we land on green? Now, this isn't asking for probability anymore. This is asking how many times would we predict that we land on green. Okay, so in order to get this one, we need to take the probability and we need to multiply it times the number, and that's a number, not a hashtag symbol. We need to multiply it times the number that we spin. So if we find our probability of landing on green, so we write this as probability of green, we need to multiply that times 10 to get our answer. Okay, so if we spin this 10 times, how many times will we land on green? Well, we know that there are 5 total, and there are 2 greens. So that's 2/5. Now, if I turn this into a percentage, okay, that would be 20%. 40%. Whoops, that could have been bad. It's 40%. I could take 40% times 10, but if I did that without a calculator, I have to use the whole algorithm. It takes a long time. So you could do it this way, but you could also just leave it as a fraction. 10 over 1. And then I just multiply my fraction. I get 20/5, which is 4. So I know that if I spin this 10 times, I will land 4 times on green, which actually makes sense if you think about it, because if 2 out of 5 spins gives me green, well, then 4 out of 10 has to give me green as well. So they have to be equal. Now this one gets a little bit tougher. If we spin it 20 times, how many times will we hit red? Well, okay, same thing. We got to find the probability. So that'll be 3 out of 5 for red. And we take that times our 20. Now, once again, I could turn this into a percentage and multiply, but fractions are so much easier here. So I'm going to make this 60 over 5. Okay, and so I got to turn that into a whole number. Well, if I think about it, 50 over 5, well, that's 10. So then 55 over 5, that's 11. So then 60 over 5 has to be 12. So if I spin this 20 times, I expect to hit red 12 of those 20. Okay, so now that we've covered simple probability, we got to go back to this question and really think about it again. What is the probability of landing or pulling a red from each of the bags? Which bag is more likely? Well, here's the thing. We have to find the probabilities of each. So for the first bag, we have 3 red. And we have 3, 5, 9 total. That simplifies down to 1/3, which is as a percentage 33%. Now the other bag, I have 4 red, and I have 9, 15, 17. Okay, so if I took this would be calculator, definitely. So 4 out of 17 ends up being about 23.5%. So here's the problem, right? I know that I have a better chance of getting a red ball out of the left side bag. I have a better probability, but experimental probability tells me that I just might not get a red ball out of it anyway. So what I want you to do is really think about this, and then if you come and talk to Mr. Schmidt and tell him what you think is a better choice in this situation, you can get a piece of candy.